These are the extra practice problems for Chapter 1 in chemistry. So in number 1, you're just asked to state how many significant figures. So first one is 106 milliliters. So 1, 2 are significant, and the 0 is significant because it is between two other significant figures. So the answer to that one would be 3. B, 1.20 times 10 cubed centimeters. So the non-zeros are significant, and this is significant because it's to the right of the decimal place and at the end of the number. So that also would be 3 significant figures. Okay, C, 3.400 kilograms. The non-zeros are significant, and this is significant. The last one is significant because it's to the right of the decimal place and at the end. And then this one would be significant because it is between two other significant figures. So for C, the answer is 4 significant figures. And then D, 0.0006700 inches. Okay, so the non-zeros are significant. None of these are significant because they're to the right of the decimal place. These three are to the right of the decimal place, but they're not at the end. And this one is to the left of the decimal place, so it's not significant. So then what about these 3? Well, this one would be significant because it is at the end. And then these 2 would be significant because they are between two significant figures. So the answer to that one is 5 significant figures. Okay, number 2. What is the correct answer to the following equation? 18 grams plus 1.6912 grams. So if we just do the math, if we just do the adding, we would get 19.6912 grams. We need to look at significant figures, and when adding or subtracting, we look at place value. So this, even though this answer goes out to the tenths, hundredths, thousandths, 10,000ths, this one only goes out to the ones place. So we can only report our answer out to the ones place. So is it 19? It's not 19 because of the 6. We need to round it up. So going out to the ones place, our answer would be 20 grams. The length of a pin is 0.0258 meters. What is its length in milliliters? Okay, so using the factor label method, we put the number that we want to convert, we put that over 1. And then the units that we want to end up with goes on the top. So we're going to put millimeters on top, and we know that there are 1,000 millimeters in a meter. So meters cancel. So 0.0258 times 1,000, we'll move the decimal place 3 places, 1, 2, 3. So the answer is 25.8 millimeters. And let's make sure about significant figures. So up here we have 1, 2, 3 significant figures. So we have 1, 2, 3 significant figures there. Okay, number 4. The mass of a stone is 56.1 kilograms. What is the mass in grams? Okay, so we want to convert that, so that goes over 1. And we want to end up with grams, so grams are going to go on the top. Kilograms will go on the bottom, and we know that there are 1,000 grams per kilogram. So the kilograms, one on the top, one on the bottom, is going to cancel. So 56.1 times 1,000 divided by 1 is going to give us, we're going to move the decimal place 3 places to the right, 56,100 grams. This has 3 significant figures, and this also has 3 significant figures. The 5, the 6, and the 1 are significant. Number 5. The volume of a container is 0.005 kiloliters, and we want to know how many milliliters is that. Okay, so 0.005 kiloliters, we'll put that over 1. And to get from kiloliters to milliliters, we have to first go through liters. So we know we want to get liters, we're going to end up with liters in this step, and we want the kiloliters to cancel. We know there are 1,000 liters in a kiloliter, so that gets rid of the kiloliters. Now we have liters and we need to get to milliliters, so milliliters is going to go on the top, and the liters will go on the bottom, so that the liters now cancel, and there are 1,000 milliliters per liter. So 0.005 times 1,000 times 1,000 will give us 5,000 milliliters. One significant figure here, one significant figure in our answer. Okay, number 6, an object has a length of 3.45 meters. What is its length in inches? Okay, so the 3.45 is the unit that we want to convert, so that's going to go over the number 1. And it says, what is the length in inches? So inches is going to go on top. And meters will go on the bottom. And, sorry, I skipped a step there. So it asks us, so we know that 2.54, there's 2.54 centimeters equals 1 inch. Okay, so again, it's a 2-step process. We got to get meters to centimeters, and then we can go from centimeters to inches. Okay, so there are 2.54 centimeters per meter. Okay, so the meters are going to cancel. And now we want to end up with inches, so we'll put the inches on top. And we'll put centimeters on the bottom because we want them to cancel. And what we know is that there are 2.54 centimeters in 1 inch. So 2.5 centimeters per inch. So now centimeters are going to cancel. You know, I'm sorry, I made a mistake back here. There are 100 centimeters in a meter. Okay. Let me start over so I don't confuse anybody. Okay, so we started out with 3.45 meters. And we want to get that into inches. Okay, so we first have to go to centimeters and then from centimeters to inches. So there are 100 centimeters per meter. So put the value that you want to convert over 1, and then the unit that you want to end up with goes on top. So 100 centimeters per meter, so the meters cancel. And now we're in centimeters, and now we can multiply that times 1 inch, which is what we want to end up with. And 1 inch is equal to 2.54 centimeters. And so centimeters will cancel, we'll be left with inches. So 3.45 times 100, so we're going to multiply across the top and divide by the bottom, divide by 2.54, and you will end up with 135.826717 inches. Okay, so then we have to look at our significant figures, and we'll look at this number. These are the conversion factors are deemed to have an infinite precision, and therefore an infinite number of significant figures, even though we don't write them all. So we look at the 3.45, so that we can have 3 significant figures. So that means that this would be 136 inches. Okay, number 7. Convert the following measurements into scientific notation with 4 significant figures. Okay, so A is 17000 kilograms. So first of all, get our 4 significant figures. So 1.700 times 10 to the, so how many places do we have to move the decimal place to the left? 1, 2, 3, 4. 10 to the 4th kilograms. Okay, next is B is 0.01670 meters. Okay, so 4 significant figures. 1.670 times 10. So how many places do we move the decimal place to the right to get our 3 significant figures? So we're going to move it 1, 2. So this will be times 10 to the negative 2 meters. Okay, C, 0.008761 milligrams. So 4 significant figures, 8.761 times 10 to the 1, 2, 3. Moved it to the right, so it's a negative 3 milligrams. And then lastly, D is 5.12 times 10. Oops, sorry. D is 120 kilometers. Okay, so 4 significant figures is going to be 1.200 times 10. Okay, so our decimal place is here. 1. Our decimal place is here, so it's going to go 1, 2 places. And if we moved it to the left, so it would be 10 squared kilometers. 1.200 times 10 squared kilometers. Okay, number 8. Number 8, we're converting scientific notation into decimal notation. So A is 7.21 times 10 cubed kilometers. Okay, so we want to convert that to decimal. So we are going to move the decimal place 3 places to the right. So it would be 1, 2, and then add a 0, it would be 3. So 7,210 kilometers. And we had 4 significant figures up there. No, we had 3 significant figures, and we have 3 significant figures in our answer. Okay, B, 1.17 times 10 to the negative 5 milliliters. Okay, so we need to move the decimal place 5 places to the left. Okay, so there's, so we start with 1.17. So 1 place would get it there, 2, 3, 4, 5. So our decimal place goes right there. So 0, 0, 0, 0, 1, 1, 7. Okay, then C is 3.112 times 10 to the 8th kilograms. Okay, so we're going to move our decimal place 8 places to the right. So we start here. 1, 2, 3, 4, 5, 6, 7, 8. So 3, 1, 1, 2, 1, 2, 3, 4, 5. We'll put our, so 311,200,000, and we can't forget our units, so it's kilograms. And then D is 5.12 times 10 to the negative 7. And the units are meters. Okay, so we're going to start with that 5.12, and we are going to move our decimal place 7 places to the left, since it's a negative exponent. So 1 gets us there, 2, 3, 4, 5, 6, 7. So decimal place is there. 0.000, 000, 000, 512. So 6 zeros and 512, and we can't forget our units, so it's meters. Okay, that's number 8. Number 9. A container has a volume of 750 cubic centimeters. What is its volume in liters? Okay, so the first thing you have to realize, the first thing you have to remember is that a cubic centimeter is the same as a milliliter. So essentially you have 750 750 milliliters. I'm going to put that over 1. We want to end up with liters, so liters goes on top and milliliters goes on the bottom. And we know that there are 1,000 milliliters in a liter. So milliliters cancel. 750 divided by 1,000, 0.75. We can only have 2 significant figures because this number has 2 significant figures. So 0.75 liters. Number 10, a sample of liquid has a volume of 0.013 cubic meters. What is its volume in liters? Okay, so as we think through this problem, again, remember that a cubic centimeter is equal to a milliliter. Okay, so we have cubic meters. So the first thing we have to do is get our answer into cubic centimeters, and then once we have it in cubic centimeters, then we know that that's the same as milliliters, and then we can convert milliliters to liters. Okay, so 0.013 cubic meters. So we have to get rid of meters 3 times. So there are 100 centimeters in a meter. Get rid of 1 of these. So now we're down to 2. Then we do that again, 100 centimeters per meter. That gets rid of another 1. So now we're down to 1. And then again, 100 centimeters per meter. That gets rid of the last one. So the meters are gone, and we have centimeters times centimeters times centimeters, which is cubic centimeters. So if you 0.013 times 100 times 100 times 100 will give us 100 or 13,000 cubic centimeters. And remember, we said that a cubic centimeter is the same as a milliliter. So 13,000 milliliters. Now we can convert that to liters, which is what the problem asks us for. So 13,000 milliliters, put that over 1, and we want liters, so 1 liter is equal to 1,000 milliliters. So milliliters cancel, and you're left with liters. 13,000 divided by 1,000 is equal to 13 liters. Now we go all the way back up to the beginning. So up here we had 2 significant figures, so our answer can have 2 significant figures. Okay, number 11 is both 11 and 12 are density problems. So remember that density is equal to mass divided by volume. So this says that silicon has a density of 2.3 grams per milliliter, and it has a mass of 1.72 kilograms. Okay, so the first thing you should realize is that we can't deal with grams and kilograms together, so we need to convert the kilograms to grams. So 1.72 kilograms over 1. And we want to end up with grams, so grams is going to go on the bottom, on the top, and there are 1,000 grams in a kilogram. So the kilograms are going to cancel. So then the mass is 1,720 grams. Okay, that's the mass. Okay, and we need to solve for volume. Okay, so density equals mass divided by volume. We need to get volume by itself. So multiply both sides by volume. That gets that over there. And then divide both sides by density. So that gets rid of density over here. So that volume is equal to the mass divided by the density. Okay, so the mass we said was in grams was 1,720 grams, and the density that we were given for silicon is 2.3 grams per milliliter. So grams, we have a gram on the bottom and a gram on top. That's going to cancel. And when this is like 1 over a milliliter, and so dividing by a fraction is the same as multiplying times a reciprocal. It just means that that milliliter is going to go up on top. So that's the units that we'll be left with. So 1,720 divided by 2.3, the volume will equal 747.826, maybe 0.87, something like that. And our answer is in milliliters, but now we have to look at significant figures. So we were given this density of 2.3 at the, so that is the least precise measurement, so we are limited to 2 significant figures. So this would need to be 750 milliliters, or you could write it 7.5 times 10 squared milliliters. Either one is okay because both of them will give you 2 significant figures. Okay, then the last one is number 12, also a density problem. What is the mass of a silicon block that has a volume of 0.45 liters? Okay, so the volume, 0.45 liters, is equal to the volume. We want to know what is its mass. And in the previous problem, we were given the density. So the density was 2.3 grams over milliliters. That's going to be equal to density. Okay, so again, first of all, recognize that you can't deal in both milliliters and liters. So we need to convert this as liters to milliliters. 0.45 liters. Okay, that's the unit we want to convert, so we'll put that over 1. And we want to end up with milliliters, so milliliters goes on top. And we know that there are 1,000 milliliters in a liter. So liters are going to cancel. And for the volume, then you will get, if you do that math, you'll get 450 milliliters is equal to the volume. And 2 significant figures here, 2 significant figures there. Okay, so we're solving for mass. So density is equal to mass divided by volume. So to solve for mass, we're going to multiply both sides times volume. So that gets rid of that there. So the volume times the density is equal to the mass. So the volume was, we figured it out before as 450. So 450 milliliters. And we will multiply that times the density, which was 2.3 grams per milliliter. That will equal the mass. Okay, so we have a milliliter on top and a milliliter on bottom. Those are going to cancel. So the units that we're left with is grams, and that is a proper unit for mass. So 450 times 2.3, you will get something like 1,035 grams. Okay, but then if we look at our significant figures, we're limited really by this and also by this to two significant figures. So we have to get this number into two significant figures, and the only way we can do that is to use scientific notation. So this would be 1.0, there's our two significant figures, times 10 cubed grams. Okay, so that finishes up the extra practice problems for chapter 1.